Hello, in this lecture we'll answer on two questions. In the first question, we'll find out the side length of square ABCD, and in the second question, we will find out the length of line segment AD that is equal to x. Okay, so we'll start with the first question. Here in the drawing we have square ABCD. We know that the short line segment DE equals to 1 unit, and we also know that the radius of this circle is equal to 2 units, and we want to find out the length of one side of square ABCD. Okay, so first of all, we know that the radius of this circle equals to 2 units, so here we will define the point of tendency of tangent AD with this circle as point M. We will define the center of this circle as point O, and we will join points M and O together by a straight line. M is the point of tendency of tangent AD with this circle, and MO, line segment MO, is the radius of this circle, so we'll define the radius of this circle as R, and we know that R equals to 2 units, so here we have the radius of this circle that is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency of tangent AD with this circle. And whenever you have a radius that is drawn to the point of tendency, then the tangent AD will be perpendicular to the radius MO. So AD is perpendicular to MO. That is to say, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. We will define the point of tendency of tangent AB with this circle as point L, and we join points L and O together by a straight line. Here, line segment LO is the radius of this circle. Why? Because it starts from the center of the circle and ends at point L, that is the point on the circle itself. This is exactly the definition of a radius. So OL, it is equals to R, that is 2 units. So here we have the radius OL, it is drawn to the point of tendency, that is to say OL is drawn to point L, that is the point of tendency of tangent AB in this circle. And whenever you have a radius that is drawn to the point of tendency, then the tangent AB will be perpendicular to the radius LO. So AB is perpendicular to LO, that is to say this angle equals to 90 degrees, and this angle will also equal to 90 degrees. Okay? It is given us the question that quadrilateral ABCD is a square, and we know that all the angles inside the square are right angles. That is to say, angle DAB, it is 1 out of 4 angles of square ABCD. Therefore, it will be equal to 90 degrees. So actually in quadrilateral MOAL we have one, two, three right angles. Again, in quadrilateral MOAL we have one, two, three right angles. Okay, I write it down. In quadrilateral MOAL we have three right angles. The sum of three right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle, that is actually angle MOL, this angle. In total, the sum of those four angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we subtract 270 degrees from this equation, and we get that the missing angle, angle MOL, is equal to 360 degrees minus 270 degrees, it is 90 degrees. Okay, so we found out that the missing angle is a right angle, it is equal to 90 degrees. This angle equals to 90 degrees. So actually we found out that all the angles inside quadrilateral MOEL are right angles. Okay, and any quadrilateral that has four right angles must be at least a rectangle. So we relate to quadrilateral MOAL as a rectangle because of the fact that it has four right angles. Okay, quadrilateral MOAL is a rectangle. Actually, it is at least a rectangle, so we will relate it as a we relate to it as a rectangle. It could be also a square, but it must be at least a rectangle. And we know that the opposite sides of a rectangle are equal to each other. So in rectangle MOAL, according to the rule that the opposite sides of a rectangle are equal to each other, we get that MO must be equal to AL. MO must be equal to AL. MO must be equal to AL, according to the rule that the opposite sides of a rectangle are equal to each other. But MO equals to 2 units. It is the radius of the circle, so we can write here MO equals to 2. And from this equation, 2 equals to MO equals to AL. We will derive that AL is also equals to 2 units. Okay, AL equals to 2 units. Likewise, in rectangle MOAL, OL must be equal to MA. OL must be equal to MA according to the rule that the opposite sides of a rectangle are equal to each other. But here we have already found out that OL equals to 2 units. It is the radius of the circle. So we can write here that OL equals to 2 units. And from this equation, we will derive from this equation OL equals to MA. We will derive that MA is also equals to 2 units. MA is also equals to 2 units. So all the sides of quadrilateral MOAL are equal to each other, therefore quadrilateral MOAL is a square. Okay, you can write down that quadrilateral MOAL is a square. Okay. And we actually have also rule number 2. According to rule number 2, the lengths of two tangents from a common external point to a circle are equal. I'll repeat again on rule number 2. Again, according to rule number 2, the lengths of two tangents from a common external point to a circle are equal. So if you have a common external point, any common external point, and from the common external point you draw two tangents to a circle, then the lengths of those two tangents must be equal to each other. We already discussed this rule, so I'll not repeat on it. We can implement rule number 2 in our drawing, because if we focus at point E is a common external point, from the common external point E, we have two tangents to the circle. The first tangent to the circle from point E, from the common external point E, is tangent EM, and the second tangent is this tangent, so we'll define the point of tangency of tangent DB with this circle as point H. So the second tangent to this circle from point E is tangent EH. And according to rule number 2, the lengths of those two tangents are equal to each other. This is to say EM equals to EH according to rule number 2. Okay. And what is the length of EM from the drawing? So first of all, we define the length of one side of square ABCD as x. So here DA of AD will be equal to AB, and it also will be equal to BC. It will be equal to DC, and all those sides, they are equal to x according to our definition. Okay, here I repeat again. The square ABCD, AD equals to AB equals to BC equals to DC equals to x according to our definition. We know that DE equals to 1 unit and AM equals to 2 units, so we will get that EM, the length of line segment EM, it will be equal to AD minus DE, the short line segment, minus AM. Okay, I'll repeat again. The length of line segment EM equals to AD minus DE minus AM. So EM equals to AD, that is x according to our definition, minus DE, that is 1 according to what is given us in the question, minus AM. AM equals to 2 units according to what we have already found out. Okay, so in conclusion, we found out that EM equals to x minus 1 minus 2, and x minus 1 minus 2 equals to x minus 3. So EM equals to x minus 3. EM equals to x minus 3. So we already found out that EM equals to E edge according to rule number 2. And we just right now found out that EM equals to x minus 3. So we can add here that EM equals to x minus 3. And from this equation, x minus 3 equals to EM equals to E edge, we will derive that E edge is also equals to x minus 3. E edge equals to x minus 3. Okay, E edge equals to x minus 3, so I can write in the drawing that E edge equals to x minus 3. First of all, EM equals to x minus 3. And E edge is also equals to x minus 3. So in the next step, we will focus on the common external point B. From the common external point B, we have two tangents to the circle. So here we have, from this point we have two tangents to the circle. The first tangent is tangent BL, and the second tangent is tangent BH. And according to rule number 2, the lengths of those two tangents are equal to each other. That is to say, BL is equal to BH according to rule number 2. So what is the length of BL? From the drawing it is very easy to see that BL equals to AB minus AL. Again, BL equals to AB minus AL. AB minus AL equals to BL. Okay, BL equals to AB minus AL. That is to say, BL equals to AB. AB equals to X according to our definition. AL equals to 2 units according to what we have already found out. So in conclusion, we found out that BL equals to X minus 2. So BL equals to X minus 2. BL equals to X minus 2. Okay. And right here that BL equals to X minus 2. So we have this equation according to rule number 2. BL equals to BH, and we just right now found out that BL equals to X minus 2, so we can write here that BL equals to X minus 2, and from this equation X minus 2 equals to BL equals to BH, we will derive that BH is also equals to X minus 2. BH is also equals to X minus 2. So here, BH equals to X minus 2. Okay. So we actually know that triangle EAB is a right triangle because of the fact that angle EAB equals to 90 degrees. Okay. So we'll focus on the right triangle, triangle EAB. So I'll copy the right triangle EAB in a new page and we'll implement the Pythagoras theorem on the right triangle EAB. So what is the length of EA? The length of EA, it will be EA equals to AD minus DE. AD minus DE equals to EA. Okay, I'll repeat again. AD minus DE equals to EA. Okay. So actually EA, this side equals to AD equals to X according to our definition, minus DE equals to 1 unit according to what is given as the question. So in conclusion, we found out that EA equals to X minus 1. Here, what is the length of side AB? Side AB equals to X according to our definition. AB equals to X. Okay, AB equals to X. And what is the length of the hypotenuse EB? The length of the hypotenuse EB, it is equal to EB equals to X minus 3 plus X minus 2. X minus 3 plus X minus 2. So EB equals to X plus X is 2X. Minus 3 minus 2 is minus 5. Minus 3 plus minus 2 is minus 5. So in conclusion, we found out that the hypotenuse EB equals to 2X minus 5 units. Now we will implement the Pythagoras theorem on this right triangle, triangle EAB. So here, by PT is abbreviation for Pythagoras theorem. PT is Pythagoras theorem. Okay. And this will be equation number 1. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is EB, and the square of the hypotenuse is EB squared, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to EA squared plus AB squared. Okay. So we just lines now found out that EB equals to 2x minus 5, so we substitute EB by 2x minus 5. So if EB equals to 2x minus 5, it means that EB square equals to 2x minus 5 square, and it is equal to EA square. EA equals to x minus 1, so EA square will be equal to x minus 1 square plus AB square. AB equals to x, so AB square will be equal to x squared. So in conclusion, we found out that according to equation number 1, 2x minus 5 square equals to x minus 1 square plus x squared. Here we will open the brackets on both sides of this equation, equation number 1. We will use the algebraic identity that states that a minus b square equals to a square plus b square minus 2ab. So according to the trigonometric identity that I mentioned, 2x minus 5 squared will be equal to 2x squared, that is 4x squared, plus 5 squared, that is 25, minus 2 times 2x times 5. 2 times 2x times 5 is minus 20x. And it is equal to x minus 1 squared. X minus 1 squared equals to x squared plus 1 squared, that is 1, minus 2x plus x squared. So here, so according to equation number 1, we actually found out that four x squared plus 25 minus 20x equals to x squared plus x squared is 2x squared minus 2x plus 1. I'll repeat again. According to equation number 1, I found out that 4x squared plus 25 minus 2x equals to 2x squared minus 2x plus 1. Here 2 will subtract 2x squared from this equation, equation number 1. 4x squared minus 2x squared is 2x squared. We'll also add 2x to this equation, equation number 1. So minus 2x, minus 20x plus 2x is minus 18x. And we'll subtract 1 from this equation, equation number 1. 25 minus 1 is 24. So in conclusion, I found out that 2x squared minus 18x plus 24 equals to 0. We divide the quadratic equation, equation number 1 by 2, and we get that according to equation number 1, x squared minus 12x minus 18x over 2 is minus 9x plus 24 over 2 is 9. 24 over 2 is 12, of course. That is equal to 0. So here we got the quadratic equation that x squared minus 9x plus 2f equals to 0. In this quadratic equation, the coefficient a equals to 1, the coefficient b equals to minus 9, and the coefficient c equals to 12. And the general formula for solving out the quadratic equation is x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. Here a, b and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. So we'll put the data inside this formula in order to find out the value or the values of x. And we get that here that x equals to minus b, b equals to minus 9, so minus b is minus 9, that is plus 9, plus minus square root of b squared, b equals to minus 9, so b squared is minus 9 squared, that is 81, minus 4 times A is 1, times C is 12, over 2A. A is 1, so 2 times 1 is 2. So in conclusion, we found out that x equals to 9 plus minus, inside the root we have 81 minus 4 times 12 is minus 4 times 12 is minus 48 over 2. So here we found out that x equals to 9 plus minus 81 minus 48 is 33, so inside the root we left only with 33 over 2. So here we will have two solutions that are possible for x. The first solution for x is x equals to 9 minus square root of 33 over 2. That is equal about 1.63 units. So according to the first solution, x equals to 1.63 units. But here, according to our definition, AB equals to x. AB equals to x. Okay? Side AB equals to x according to our definition. And AL, that is shorter than x, equals to 2 units. So AB is greater than 2 units. AB is greater than AL, that is to say AB is greater than 2 units. So here x must be greater than 2 units, and x that is equal to 1.63 is less than 2 units. So here x that is equal to 1.63 is less than 2 units. So, and we found out that x must be greater than 2 units, so this solution is incorrect solution. We cancel this solution and we left only with the second solution for x. That is actually x equals to 9 plus square root of 33 over 2. Okay, so x equals to 9 plus square root of 33 over 2. So x equals to 7.37 units. 7.37 units. Okay. I repeat on the answer. Here, one side of square ABCD is equal to either 9 plus square root of 33 over 2, or in terms of numbers, x equals to 7.37 units. All the sides of the square, they are equal to 7.37 units, or we can represent it also as 9 plus 4 to 33 over 2 units. Okay, here all the sides are equal to 7.37 units. Here it's equal to 7.37 units. Okay, so we finished with the first question. In the next step, I will present to you the second question, and we will solve the second question in two different methods. Okay. Here in the drawing we have triangle ABC. We know that side AB equals to A units in its length, side AC equals to 2A units in its length, BD equals to 2 units, and we want to find out the length of side AD that is equal to X. Okay, so first of all, I will present to you a new rule that is actually angle bisector theorem. Angle bisector theorem is true in any triangle so actually if we have triangle ABC, that could be any triangle. This is triangle ABC. And this is the angle bisector. AD is the angle bisector. YAD is the angle bisector because of the fact that line segment AD divides angle BAC into two halves. Each half equals to theta. For that reason, AD is angle bisector. Divides angle BAC into two halves. Each half equals to theta. So this is the angle bisector theorem. And according to angle bisector theorem, we will get that AB over AC equals to BD over DC. I repeat again. This triangle ABC, we have the angle bisector AD, and according to angle bisector theorem, AB over AC equals to BD over DC. So actually we can implement rule number 1 in our drawing, because in our drawing we have triangle ABC. In triangle ABC, AD is the angle bisector, YAD is the angle bisector because of the fact that it divides angle BAC into two halves. Each half equals to 60 degrees. So we can implement the angle bisector theorem in this triangle, triangle ABC. And according to angle bisector theorem, in triangle ABC, we get that AB over AC equals to BD over DC. Okay. AB over AC equals to BD over DC. AB equals to A, it is given as the question. So we substitute AB by A is equals to 2A, so we substitute AC by 2A, and it is equal to BC, it is actually BD, is equal to BD, this is BD of course. Again, according to angular-subtool theorem, AB over AC equals to BD over DC. AB over AC equals to BD over DC. BD equals to 2 units, according to what is given as the question, and DC is the missing line segment. So in conclusion, we found out that according to equation number 1, A over 2A equals to 2 over DC. A over A is 1, so A will get cancelled. So in this side of the equation we have 1/2 that is equal to 2 over DC. Here we will cross multiply this equation number 1, and we will get that DC equals to 2 times 2, that is 4. So DC equals to 4 units. We found out that DC equals to 4 units, so we can write here that DC equals to 4 units. So in the next step I will present to you a new law, that is the law of sines. According to the law of sines, the law of sines is true in any triangle, so here we have okay, so here actually we will do actually the law of sines is relevant to the second method. In the first method, we will do a construction we will extend line segment CA by a straight line, and then from point B we'll draw perpendicular to the extended line segment CA. I repeat again, we did the construction by extended line segment CA by a straight line, and then from point B we will draw perpendicular to the extended line segment CA. That is to say, this angle equals to 90 degrees according to our construction. We will define the touching point of the extended line segment CA and the perpendicular from point B is E. Again, point E is defined as the touching point of the extended line segment CA and the perpendicular from point B. So actually, we created here a right triangle. Triangle EAB is a right triangle because of the fact that angle EBA equals to 90 degrees. We will focus on the right green triangle EAB. But first of all, before we focus on the right green triangle, we'll find out the length of angle EAB. First of all, CA is one side of triangle ABC, therefore it is absolutely a straight line. And when we actually extended the straight line CA by a straight line. And when you extend a straight line by a straight line, the result must be a straight line. That is to say, CE is a straight line. Okay, we extended the straight line CA by a straight line and we got the line segment CE. And when you extend the straight line by straight line, the result that is CE must be also a straight line. So we can write down that CE is a straight line. And we have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on this side of the straight line EC, this is the straight line EC, on this side of the straight line EC at point A, so here on this side of EC at point A, the sum of the angles must be equal to 180 degrees. Okay, so which angles we have at point A? So here we have 60 degrees plus 60 degrees plus angle EAB. 60 degrees plus 60 degrees plus angle EAB. In total, the sum of those three angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line equals to 180 degrees. So 60 degrees plus 60 degrees plus the size of angle EAB. In total, the sum of those three angles must be equal to 180 degrees. 60 degrees plus 60 degrees is 120 degrees. So we subtract 120 degrees from this equation and we get that the missing angle EAB, equals to 180 degrees minus 120 degrees, it is 60 degrees. Okay, here we found out that the missing angle EAB equals to 60 degrees. Now we'll focus on the green triangle EAB. On the green triangle, the green right triangle EAB, we know that sinus 60 degrees, cosine 60 degrees, cosine 60 degrees in the green right triangle equals to EA over the hypotenuse that is AB. I'll repeat again. In the right green triangle EAB, cosine 60 degrees equals to EA over AB. Cosine 60 degrees equals to EA over AB. So cosine 60 degrees equals to EA over AB. But AB equals to A according to what is given us in the question. So we'll substitute AB by A. And we'll get that cosine 60 degrees equals to EA over A. We'll multiply this equation by A, and we get that EA equals to A times cosine 60 degrees. Okay? But we know that cosine 60 degrees equals to 1/2. So we substitute cosine 60 degrees by 1/2. And we get that EA equals to A over 2. EA equals to A over 2. So we can write here that EA equals to A over 2. Okay? We'll continue to focus on the right green triangle, triangle EAB. On the right green triangle, triangle EAB, we know that sinus 60 degrees equals to EB over the hypotenuse that is AB. I'll repeat again. On the green right triangle, triangle EAB, sinus 60 degrees equals to EB over AB. So sinus 60 degrees equals to EB over AB, but AB equals to A according to what is given us in the question, so we can substitute AB by A. We substitute AB by A, and we get that sinus 60 degrees equals to EB over A. Here we'll multiply this equation by A, and we'll get that EB equals to A times sinus 60 degrees. But we know that sinus 60 degrees equals to square root of 3 over 2. We substitute sinus 60 degrees by square root of 3 over 2. And we'll get that EB equals to sinus 60 degrees, that is square root of 3 over 2 times A. So in conclusion, we found out that EB equals to square root of 3 over 2 times A units. So we can write here in the drawing that EB equals to square root of 3 over 2 times A. Okay? Now we'll focus on the big triangle, the big right triangle, triangle EBC, and we'll implement the Pythagoras theorem on the big right triangle, triangle EBC. In this way, we'll find out the value of A, of course. So, here, so in the right big triangle, triangle EBC, so actually, I will copy the right triangle, triangle ABC in the new page, and we will implement the Pythagoras theorem in the right big triangle, triangle EBC. the length for side EC, you can see from the drawing that EC equals to AC plus AE, that is to say EC equals to 2A plus A over 2. 2A plus A over 2 is 2.5A. And 2.5A is 5 over 2A. So EC equals to 5 over 2A. We have already found out that EB equals to square root of 3 over 2 times A. So EB equals to square root of 3 over 2 times A. And the hypotenuse BC, equals to 4 plus 2, that is 6. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is BC, therefore the square of the hypotenuse is BC squared. It is equal to EC squared. The sum of the square of the perpendiculars is EC squared plus EB squared. Here we'll substitute BC by 6. BC equals to 6, so BC square will be equal to 6 squared. This is 36, and it is equal to EC squared. EC equals to 5 over 2 times A, therefore EC squared will be equal to 5 over 2 times A squared plus EB squared. EB equals to square root of 3 over 2 times A, therefore EB squared will be equal to square root of 2. EB squared will be equal to square root of 3 over 2 times A squared. Okay? So here, according to equation number 2, we found out that 36 equals to 5 over 2 squared is 5 squared, that is 25, over 2 squared, that is 4, times A squared, that is A squared. So in conclusion, this expression 5 over 2A squared equals to 25 over 4A squared plus square root of 3 over 2 squared equals to square root of 3 squared, that is 3, over 2 squared, that is 4, times A squared. So in conclusion, we found out that according to equation number 2, 36 equals to 25 over 4A squared plus 3 quarters A squared. Here we take 4 as a common factor in this side of the equation, so here we get that according to equation number 2, 36 equals to 25 plus 3 is 28 over 4A squared. So 36 equals to 28 over 4 is 7. So in conclusion, we found out that according to equation number 2, 36 equals to 7A squared. Here we will divide this equation number 2 by 7, and we get that A squared equals to 36 over 7. A squared equals to 36 over 7. Here we take a root out of this equation number 2, and we get that according to equation number 2, A equals to the square root of 36 is 6 over square root of 7. So we found out that A equals to 6 over square root of 7 units. In the next step, I will present to you a new rule that is related to angle bisector, to the angle bisector. So here it will be rule number 3. According to rule number 3, if we have a triangle ABC, that could be any triangle, this is triangle ABC, and we have also the angle bisector. AD is angle bisector because it bisects angle BAC into 2 halves, each half equals to theta. And according to rule number 3, we'll get that AD square equals to AB times AC minus BD times DC. I'll repeat again. If we have triangle ABC, that could be any triangle, and we have the angle bisector AD, then according to rule number 3, AD squared, that is the angle bisector squared, equals to AB times AC minus BD times DC. We can implement rule number 3 in triangle ABC. Why? Because triangle ABC has the angle bisector AD. Here we have triangle ABC. Triangle ABC has the angle bisector AD, so we can implement rule number 3 in triangle ABC. So I'll copy triangle ABC in the new page, and we will implement the angle bisector theorem on triangle ABC. This is triangle ABC. We have the angle bisector AD. BD equals to 2 units, DC equals to 4 units, AB equals to A, and AC equals to 2A. Okay, so we implement the angle bisector theorem in this triangle ABC. According to angle bisector theorem, we get that AD square, AD equals to X, according to what is given as the question. So we get that, according to rule number 3, we get that AD square, this is rule number 3, equals to AB times AC minus BD times DC. Okay, AD equals to X, so AD square is X squared. And it is equal to AB. AB equals to A times AC. AC equals to 2A minus BD is 2 times DC is 4. Okay, so in conclusion, we found out that X squared equals to A times 2A minus 2 times 4. That is to say, according to equation number 3, X squared equals to A times 2A is 2A squared, minus 2 times 4 is minus 8. So X, according to equation number 3, X squared equals to 2A squared minus 8. But we have already found out that A squared equals to 36 over 7. So we substitute a squared by 36 over 7. Here it is minus 8. So here I'm putting the equation number 3. X squared equals to 2 times 36 is 72 over 7. Here we multiply 8 by 7 and then we divide it by 7 in order to have a common factor with this expression. So 7 minus 8 times 7 is minus 56. So we found out that x squared equals to 72 minus 56 over 7. And 72 minus 56 is 16 over 7. So we found out actually that according to equation number 3, we found out that x squared equals to 16 over 7. Here we take a root out of this equation, equation number 3, and we get that according to equation number 3, x equals to the square root of 16 is 4 over square root of 7. So we found out that x equals to 4 over square root of 7 units. In terms of numbers, it is equal to 1.51 units. Okay, so the answer to the question is that x equals to either 4 over square root of 7 units, or in terms of numbers, it is equal to 1.51 units. So here, you can write here that AD that is equal to x, it is equal to either 4 over square root of 7 units, or in terms of numbers, it is equal to 1.51 units. Okay, we finished with the first method. In the next step, I will present to you how to find out the value of side AD that is equal to x according to the second method. Okay. In the second method, we define angle ADB is theta, and we know that BC is one side of triangle ABC. So BC is a side of a triangle, it must be a straight line. It is absolutely a straight line. Okay? And we know that the sum of the angles on one side of a straight line is equal to 180 degrees. So on this side of the straight line BC, at point D, the sum of the angles must be equal to 180 degrees. So if this angle is theta, then this angle must be equal to 180 degrees minus theta. Okay, so in the next step I present to you the law of sines. Here, the law of sines is true in any triangle. So if we have triangle ABC that could be any triangle, this is triangle ABC. Side BC equals to A units in its length. side AC equals to B units in its length, and side AB equals to C units in its length. Then according to the law of sines, we get that A over sine A here capital A is the size of angle BAC equals to B over sine B. Again, capital B is the size of angle ABC, and it is equal to C over sine C. Okay, sine C. C is the size of angle ACB. Okay, in any triangle, A over sine A equals to B over sine B equals to C over sine C. You can implement the law of sines in triangle. We will implement the law of sines in triangle ABD. In triangle ABD, this triangle ABD, we get that A over sinus theta equals to 2 over sinus 60 degrees. This is the implementation of the law of sines in this triangle ABD. Okay, then we'll focus on triangle ADC and we'll implement the law of sines in this triangle ADC. In triangle ADC, according to the law of sines, we'll get that CD over sinus 60 degrees equals to 2A over sinus 180 degrees minus theta. Okay, this is equation number 2. But we have the trigonometric identity, the sinus 180 degrees minus theta equals to sinus theta. That is to say, we can substitute sinus 180 degrees minus theta in this equation number 2 by sinus theta. We'll do it now and we'll get that according to equation number 2, CD over sinus 60 degrees equals to 2A over sinus 180 degrees minus theta equals to sinus theta according to this trigonometric identity. So here we have A over sinus theta. In equation number 2 we have the expression A over sinus theta. But according to equation number 1, the expression A over sinus theta equals to 2 over sinus 60 degrees. That is to say, we can substitute A over sinus theta in equation number 2 by 2 over sinus 60 degrees from equation number 1. We'll do it now, and we get that according to equation number 2, CD over sinus 60 degrees equals to 2 times A over sinus theta. But A over sinus theta according to equation number 1 equals to 2 over sinus 60 degrees. So we substitute A over sinus theta by 2 over sinus 60 degrees, and we will get that according to equation number 2, we found out that CD over sine of 60 degrees equals to 2 times 2 over sine of 60 degrees. We have sine of 60 degrees on both sides of equation number 2, so sine of 60 degrees will get cancelled. And we have to leave CD, it is equal to 2 times 2. So CD equals to 2 times 2, that is 4. So I found out that CD equals to 4 units. So we can write here that CD equals to 4 units, exactly as we found in the first method. Okay. In the next step, I will present to you the law of cosines. The law of cosines is true in any triangle, so if we have triangle ABC, that could be any triangle. This is angle theta. Side BC equals to C units in its length. Side AB equals to A units in its length. And side AC equals to B units in its length. Then, according to the law of cosines, we get that cosine theta equals to A square plus B square minus C square over 2 times A times B. In any triangle, according to the law of cosines, A square plus B square minus C square equals to, actually cosine theta equals to A square plus B square minus C square over 2 times AB. We will implement the law of cosines in triangle ABC. Okay, so according to the law of cosines in triangle ABC, cosine 60 degrees plus 60 degrees is 120 degrees. So cosine 120 degrees equals to AB square. AB square is A square because AB equals to A plus AC square. AC equals to 2A, so AC square is 2A square. Minus C square. C square is, C is BC. BC equals to 6. 4 plus 2 is 6. 6 square is 36. Over 2 times A times B. AB equals to A and AC equals to 2A. So in conclusion, according to the law of cosines, we actually found out that cosine 120 degrees equals to A square plus 2A square plus 36 over 2A times 2A. Cosine 120 degrees equals to minus 1/2. That is equal to A square plus 2A square. 2A square is 4A square, and 4A square plus A square is 5A square, minus 36 over 2A times 2A. Here we have 2 on both sides of the equation, so 2 will get cancelled. In the next step, we will cross multiply this equation, and we get that A times 2A is 2A square, and 2A square minus 1 is minus 2a squared. That is equal to 5a squared minus 36. We will add 2a squared to this equation and we will add 36 simultaneously, and we get that 7a squared equals to 36. We divide this equation by 7 and we get that a squared equals to 36 over 7. Here we take a root out of this equation and we get that a equals to the square root of 36 is 6 over the square root of 7. So a equals to 6 over the square root of 7. In the next step I will present to you a new way to calculate the area of any triangle. If we have this triangle ABC, that could be any triangle. This is triangle ABC. This is angle theta. The left of side AB is A units and the left of side AC is B units. Then according to the new formula, the area of triangle ABC, this is the sign for the area, it is equal to AB sinus theta over 2. Okay, AB sinus theta over 2. We will implement the new formula to calculate the areas of the triangles in our drawing. So here the area of triangle ABC equals to A times B times sinus theta over 2. Okay, so here we know that triangle ABC consists of two small triangles, triangle ABD and triangle ADC. And the area of triangle ABC equals to the area of triangle ABD plus the area of triangle ADC. It's very easy to see it from the drawing. So we can write down that the area of triangle ABC equals to the area of triangle ABD plus the area of triangle ADC. And the area of triangle ABC according to the new formula is equal to A times 2A times sinus 60 degrees plus 60 degrees is 120 degrees over 2, and it is equal to area of triangle ABD. The area of triangle ABD, according to the new formula, will be equal to A times X times sinus 60 degrees over 2, plus the area of triangle ADC. The area of triangle ADC, according to the new formula, is equal to X times 2A times sinus 60 degrees over 2. Okay. We know that sinus 120 degrees equals to sinus 60 degrees. So we can divide this equation by sinus 60 degrees. So sinus 60 degrees will get cancelled, and sinus 120 degrees equals to sinus 60 degrees. We have 2 on both sides of the equation in the denominator, so 2 will also get cancelled. And we have A on both sides of the equation, so A will also get cancelled. A, and A. So what is left after we cancelled all the variables here? In this side of the equation we have 2a is equal to x plus 2x. So 2a equals to x plus 2x is 3x. We divide this equation by 2 and we get that x equals to, we divide this equation by 3 and we get that x equals to 2 over 3 times a. X equals to 2 over 3 times a. But we have already found out that a equals to 6 over square root of 7 units. So we substitute a by 6 over square root of 7 units. And we get here 6 over 3 is 2. And 2 times 2 is 4. So in conclusion, we found out that x equals to either 4 over square root of 7 units, or in terms of numbers, it is equal to 1.51 units. Okay? Exactly as we found in the first method. Okay, x equals to 4 over square root of 7 units, or in terms of numbers, it is equal to 1.51 units. So in the next step, I will summarize the lecture. We will start with the first method. We'll start with the first question, of course. So in the first question, we have square ABCD. Inside the square we have this circle. Line segment D equals to 1 unit. The radius of this circle is 2 units. And we want to find out the side length of square ABCD. Okay, so here we defined the center of this circle as point O. And we define the point of tendency of tangent AD with this circle as M, and we define the point of tendency of tangent AB with this circle as L. Then from point, we join points O and M together by a straight line. What is the definition of OM? O is the center of the circle. M is the point on the circle itself. This is exactly the definition of a radius. So OM is the radius of this circle that is defined by us by the radius of the circle is defined by us by as R. Small r is the radius of this circle, and we know that r equals to 2 units. So here we have the radius OM that is drawn to the point of tendency. That is to say, it is drawn to point M, that is the point of tendency of tangent AD with this circle, and whenever we have a radius that is drawn to the point of tendency, then the tangent AD will be perpendicular to the radius MO. So AD is perpendicular to MO, that is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. Okay? Then we join points O and M together by a straight line. OM is the radius of the circle for the same reason. It starts from the center of the circle and ends at point L, that is the point of the circle itself. So OL is the radius, and the radius of OL it is drawn to the point of tendency. And whenever we have a radius that is drawn to the point of tendency, then the tangent AB will be perpendicular to the radius LO. So AB is perpendicular to LO. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. And we know that ABCD is a square, and all the angles inside the square are right angles. That is to say, angle DAB equals to 90 degrees. So inside quadrilateral MOAL, we have 1, 2, 3 right angles. And the sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle, that is actual angle MOL. In total, they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. We subtract 270 degrees from this equation, and we found out that the missing angle MOL, this angle equals to 90 degrees. So quadrilateral MOAL is 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle, so we relate to quadrilateral MOAL as a rectangle. And we know that the opposite sides of a rectangle are equal to each other. So in rectangle MOAL, MO must be equal to AL. MO must be equal to AL, but AL equals to 2 units. MO must be equal to AL, according to the rule that the opposite sides of a rectangle are equal to each other. Okay? But MO equals to 2 units, because MO is the radius of this circle that is equal to 2 units, according to what is given us the question. So from this equation, 2 equals to MO equals to AL, we will derive that AL is also equals to 2 units. AL is also equals to 2 units. Likewise, according to the rule that the opposite sides of rectangle are equal to each other, we get that OL must be equal to MA. OL must be equal to MA, but we have already found that OL equals to 2 units. This is the radius of the circle. So we can write here that OL equals to 2, and from this equation 2 equals to OL equals to MA, we derive that MA is also equals to 2 units. Okay, MA equals to 2 units. So actually found out that quadrilateral MOAL is a square, because all of its sides are equal to each other. Then we use rule number 2. According to rule number 2, the lengths of 2 tangents from a common external point to a circle are equal. So we focused on the common external point E, from the common external point E, we have 2 tangents to this circle. The first tangent is tangent EM, as the second tangent is tangent EH. And according to rule number 2 that they mentioned, the lengths of those 2 tangents must be equal to each other. That is to say, EM equals to EH, according to rule number 2. We defined all the sides of the square as x. So AD equals to A, B equals to B, C equals to D, C equals to x. And what is the length of line segment EM? EM equals to AD minus DE minus AM. Equals to AD minus DE minus AM. That is to say, EM equals to AD, this is equals to x according to our definition. D equals to 1 unit according to what is given as the question, and we have already found out that AM equals to 2 units. So in conclusion, we found out that EM equals to x minus 1 minus 2. X minus 1 minus 2 is x minus 3. So we found out that EM equals to x minus 3. According to rule number 2, EM equals to EH. But we just now found out that EM equals to x minus 3. So we can write down that EM equals to x minus 3. And from this equation, x minus 3 equals to EM equals to EH, we derive that EH is also equals to x minus 3. EH also equals to x minus 3. Then we focus on the common external point B. In this common external point B, from this common external point B, we have 2 tangents to this circle. The first tangent is tangent BL, and the second tangent is tangent BH. And according to rule number 2, the lengths of those 2 tangents must be equal to each other. That is to say, BL equals to BH according to rule number 2. BL equals to BH according to rule number 2. And what is the length of BL? For drawing, it is very easy to see that BL equals to AB minus AL. Again, AB minus AL equals to BL. So BL equals to AB minus AL. That is to say, BL equals to AB, this is x, minus AL, that is 2. So in conclusion, I found out that BL equals to x minus 2. So I can write in that according to rule number 2, BL equals to HB, or BL equals to BH. And we just right now found out that BL equals to x minus 2. So from this equation, x minus 2 equals to BL equals to BH, we derive that BH is also equals to x minus 2. And BH is also equals to x minus 2. Then we actually implemented the Pythagoras theorem on the right triangle EAB. Triangle EAB is the right triangle because of the fact that this angle equals to 90 degrees. Okay? So this is the right triangle EAB that I copied from the original drawing. What is the length of side EA? The length of side EA equals to DA minus DE equals to EA. Again, DA minus DE equals to EA. Okay, here EA equals to AD minus DE. That is to say, EA equals to AD, that is x, minus DE, that is 1 according to what is given as the question. So in conclusion, we found out that EA equals to x minus 1. And what is the length of the hypotenuse EB? The hypotenuse EB, you can see from the drawing that the hypotenuse EB equals to x minus 3 plus x minus 2. The hypotenuse EB equals to x minus 3 plus x minus 2. X minus 3 plus x minus 2 is 2 equals to 2x minus 5. So the hypotenuse EB equals to 2x minus 5. And the side AB equals to x according to our definition. So we implemented the Pythagoras theorem on this right triangle EAB. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The square of the hypotenuse is EB squared, that is equal to EA squared plus AB squared. EB equals to 2x minus 5, so EB squared is 2x minus 5 squared. EA equals to x minus 1, so EA squared equals to x minus 1 squared. AB equals to x, so AB squared is x squared. We open the brackets on both sides of equation number 1, and we got that 2x minus 5 equals to 2x squared minus 5 squared equals to 2x squared, that is 4x squared, plus 5 squared, that is 25, minus 2 times 2x times 5, that is minus 20x. And it is equal to x minus 1 squared. X minus 1 squared equals to x squared plus 1 squared. S squared is x squared plus 1 squared, that is 1, minus 2x plus x squared. Okay, and here we have 4x squared. On this side we have 4x squared plus 25 minus 20x, and here we have x squared plus x squared is 2x squared. Okay, so here, according to equation number 1, we actually found out that 4x squared minus 25 minus 20x equals to 2x squared minus 2x plus 1. We subtracted 2x squared from this equation number 1. 4x squared minus 2x squared is 2x squared. Here we have minus 20x and minus 2x. We added 2x to this equation number 1, so minus 20x plus 2x is minus 18x. And here we have also 25 and 1. We subtracted 1 from this equation, and we got that 25 minus 1 is 24. So in conclusion, we found out that according to equation number 1, 2x squared minus 18x plus 24 equals to 0. We divided this equation number 1 by 2, and we got that according to equation number 1, we have the quadratic equation that x squared minus 9x plus 12 equals to 0. In this quadratic equation, the coefficient a equals to 1, the coefficient b equals to minus 9, and the coefficient c equals to minus 12. And the general formula for solving out a quadratic equation is x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. Okay, so here we put the data inside the formula for x, and we found out the value or the values of x. Here x equals to minus b. B equals to minus 9, so minus b is minus 9, that is plus 9, plus minus square root of b squared. B is minus 9, so b squared is minus 9 squared, that is 81. Minus 4 times a is 1 and c is 12, so it is minus 4 times 12. Divided by 2a. A is 1, so 2a is 2 times 1, that is 2. So here x equals to 9 plus minus square root of 81 minus 4 times 12 is minus 48 divided by 2. So here we have x equals to 9 plus minus square. Inside the root we have 81 minus 48 is 33. So inside the root we left only with 33 over 2. So x equals to, so here we have two solutions that are possible for x. The first solution for x is x equals to 9 minus square root of 33 over 2. And 9 minus square root of 33 over 2 is equal to 1.63 units. But here, so according to the first solution, x equals to 1.63 units. AB equals to x according to our definition. And according to this solution, x equals to 1.63 units. But AL equals to 2 units. And AL is shorter than AB. AL is shorter than AB. That is to say, AB itself, that is equal to x, must be greater than 2. Okay, because AL equals to 2 and AB is greater than AL. So AB must be greater than 2 units. That is to say, x must be greater than 2 units, and x cannot be equal to 1.63, that is less than 2 units, because x must be greater than 2 units. Okay, so we left only with the second solution, and the second solution is that x equals to 9 plus square root of 33 over 2. So x, one side of triangle ABC, of quadrilateral ABCD, that is x, according to our definition, it is equal to either 9 plus square root of 33 units over 2, or in terms of numbers, one side of square ABCD equals to 7.37 units. So all the sides of square ABCD, they are equal to 7.37 units each. Each one equals to 37 point, each one equals to 7.37 units. So AB equals to AD equals to DC equals to BC equals to 7.37 units. This is the answer to the question. Okay, the next step, I present to you how we found out the answer to the to the second question according to the first method. So we have here triangle ABC. In triangle ABC, we know that BD equals to 2 units, angle BAD equals to 60 degrees, angle DAC also equals to 60 degrees, AB equals to A and AC equals to 2A, and we want to find out the length of side AD that is equal to x, according to what is given as a question. So here I presented to you the angle bisector theorem. According to the angle bisector theorem, if you have this triangle ABC, that could be any triangle, and AD is the angle bisector. Why AD is the angle bisector? Because it divides angle BAC into 2 halves, each half equals to theta. So according to angle bisector theorem, we get that AB over AC equals to BD over DC. Again, AB over AC equals to BD over DC. We implemented the angle bisector theorem in this triangle ABC. So in this triangle ABC, AD is the angle bisector. Therefore, we get that AB over AC equals to BD over DC. In triangle ABC, AB over AC equals to BD over DC. AB equals to A units, AC equals to 2 units. So here AB is A, AC is 2A, BD equals to 2 units according to what is given as the question, so we substitute BD by 2, and this is the missing line segment. So in conclusion, we found out that A over 2A equals to 2 over DC. A over A is 1, so A will get cancelled, and we left here with 1 half equals to 2 over DC. We cross multiply this equation, and found out that DC equals to 2 times 2. 2 times 2 is 4. So here this equals to 4 units. Okay. So here actually we made a construction. We extended line segment CA by a straight line. And after we extended line segment CA by a straight line, from point B we drew perpendicular to the extended line segment CA. Okay? From point B we drew perpendicular to the extended line segment CA. So this again equals to 90 degrees according to our construction. We defined the touching point of the perpendicular from point B and the extended line segment CA as E. So angle BEA equals to 90 degrees according to our construction. Okay, and when you extend the straight line by a straight line, the result must be a straight line. So we extended the straight line CA by a straight line, and we got line segment CE. So line segment CE must be a straight line, because when you extend the straight line by a straight line, the result must be a straight line. So CE is a straight line. So if we focus, and we have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So in the straight line CE, if we focus on this side of the straight line CE at point A, then the sum of the angles on this side of CE at point A must be equal to 180 degrees. So which angles we have at point A at this side of CE? We have 60 degrees plus 60 degrees plus angle BAE. In total, the sum of those two angles must be equal to 180 degrees. Here, 60 degrees plus 60 degrees plus angle EAB. In total must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. 60 degrees plus 60 degrees is 120 degrees, so we subtracted 120 degrees from this equation and found out that the missing angle EAB equals to 180 degrees minus 120 degrees, it is 60 degrees. So here angle EAB equals to 60 degrees. Then we focus on the right green triangle, triangle EAB. On the right green triangle, triangle EAB, we know that cosine 60 degrees equals to AE over the hypotenuse that is AB. Right green triangle EAB, cosine 60 degrees equals to EA over the hypotenuse AB. So cosine 60 degrees equals to EA over AB, and AB, the hypotenuse AB equals to A according to what is given as the question. So we substituted AB by A, and we got that cosine 60 degrees equals to EA over A. We multiplied this equation by A, and we got that EA equals to A times cosine 60 degrees. Cosine 60 degrees is 1/2, so we substituted cosine 60 degrees by 1/2, and we got that EA equals to A over 2. EA equals to A over 2. Then, in the green line triangle, triangle EAB, we know that sinus 60 degrees equals to EB over AB. Okay, here, sinus in the right triangle EAB, sinus 60 degrees equals to EB over AB. So sinus 60 degrees equals to EB over the hypotenuse AB, that is A. We substituted AB by A. Then we multiplied this equation by A, and we found out that EB equals to A times sinus 60 degrees. Sinus 60 degrees equals to square root of 3 over 2, so we substituted sinus 60 degrees by square root of 3 over 2, and we found out in conclusion that EB equals to square root of 3 over 2 times A. EB equals to square root of 3 over 2 times A units. Okay, then we implemented the Pythagoras theorem on the big right triangle, triangle EBC. So I copied the right triangle EBC in a new page, and we implemented the Pythagoras theorem on this triangle EBC. What is the length of side EC? EC equals to 2a plus a over 2. 2a plus a over 2 is 2.5a. And 2.5a is 5 over 2a. Okay? So EC equals to 5 over 2a. We already found out that EB equals to square root of 3 over 2 times a. And BC equals to 4 plus 2, that is 6. The hypotenuse equals to 6 units. Here, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say BC square equals to EC square plus EB square. BC equals to 6, so BC square is 6 square, that is 36. And it is equal to EC square. EC is 5 over 2 times a, and EC square is 5 over 2 times a square, plus EB square. EB is equal to 3 over 2 times a, so EB square is equal to 3 over 2 times a square. Here we open the brackets and we found out that 36 equals to 5 over 2 square is 25 over 4 times a square. Square root of 3 over 2 square is 3 over 4 times a square. And here we have 25 quarters plus 3 quarters is 28 quarters times a square. So we found out that 36 equals to 28 quarters times a square. 28 over 4 is 7. So in conclusion, we found out that according to equation number 2, 36 equals to 7a squared. We divided this equation number 2 by 7 and found out that a squared equals to 36 over 7. We took out of this equation number 2, and found out that a equals to the square root of 36 is 6 over square root of 7. So in conclusion, we found out that a equals to 6 over square root of 7 units. Then I presented to you a new rule that is actually rule number 3. According to rule number 3, if we have triangle ABC that could be any triangle, and we have the angle bisector AD, then AD square equals to AB times AC minus BD times DC. We implemented this new rule number 3 in triangle ABC. This is triangle ABC that I copied from the original drawing. According to rule number 3, we get that AD square equals to AB times AC minus BD times DC. Okay, AD equals to x, so AD square is x squared. AB is A, AC is 2A, BD is 2, and DC is 4. So x squared equals to A times 2A is 2A squared, minus 2 times 4 is minus 8. So x squared equals to 2a squared, but a squared equals to 36 over 7, so we substitute a squared by 36 over 7, and we got that x squared equals to 2 times 36 over 7 minus 8. 2 times 36 is 72, and here we multiplied 8 by 7, and then we divided by 7, and we got that x squared equals to 72 minus 56 over 7. 72 minus 56 is 16, so x squared equals to 16 over 7. X squared equals to 16 over 7. If x squared equals to 16 over 7, we took out of this equation and found out that x equals to square root of 16 is 4 over square root of 7. So in conclusion, we found out that x equals to 4 over square root of 7 units, so in terms of numbers it is equal to 1.51 units. We finished with the first method. Then I presented to you how to find out the length of line segment AD according to the second method. In the second method, we defined angle ADB as theta, therefore angle ADC will be equal to 180 degrees minus theta. Then I presented to you the law of sines. According to the law of sines, in triangle ABC, A over sinus A equals to B over sinus B equals to C over sinus C. We implemented the law of sines in triangle ABD. In triangle ABD, this triangle ABD, we get that A over sinus theta equals to 2 over sinus 60 degrees. And then we implemented the law of sines also in triangle ADC. In triangle ADC, CD over sinus 60 degrees equals to 2A over sinus 180 degrees minus theta. Okay? And we have the trigonometric identity that sinus 180 degrees minus theta equals to theta. So we substituted sinus 180 degrees minus theta by sinus theta, and we got that sinus CD over sinus 60 degrees equals to 2A over sinus theta. Then according to equation number 1, A over sinus theta equals to 2 over sinus 60 degrees, so we can substitute A over sinus theta by 2 over sinus 60 degrees. And so here we get according to equation number 2, CD over sinus 60 degrees equals to 2 times A over sinus theta equals to 2 over sinus 60 degrees. So we substitute A over sinus 60 degrees by 2 over sinus 60 degrees. Here we have sinus 60 degrees on both sides of the equation, so sinus 60 degrees will get cancelled. And left with CD, that is equal to 2 times 2. That is to say CD equals to 4 units. Then I presented to you the law of cosines. In any triangle, here cosine theta equals to A squared plus B squared minus C squared over 2 times AB. We implemented the law of sines in triangle ABC. So I copied the right triangle ABC in a new page, and we implemented the law of cosines in this triangle ABC. Here, according to the law of cosines, we get that cosine 120 degrees equals to A squared plus 2A squared minus 6 squared over 2 times A times 2A. Okay? Cosine 120 degrees equals to minus 1 half. A squared plus 2A squared is 5A squared minus 46 equals to 2A times 2A. We have 2 in both sides of the equation, so 2 will get cancelled. And then we cross multiply this equation and found out that minus 2A squared equals to 5A squared minus 46. Then we added 2A squared and added also 36 to this equation simultaneously, and found out that 7A squared equals to 36. Here we divided this equation by 7 and found out that A squared equals to 36 over 7. We took out of this equation and found out that A equals to 6 over square root of 7 units. And I presented to you a new formula to find out the area of any triangle. The area of this triangle equals to A times B times sinus theta over 2. We implemented the new rule to find out the area of the triangle in our drawing. We know that the area of triangle ABC equals to the area of triangle ABD plus the area of triangle ADC. Okay? So the area of triangle ABC, according to the new rule that I presented to you, will be equal to A times sinus 180 degrees over 2. The area of triangle ABD equals to A times X times sinus 60 degrees, A times A times sinus 60 degrees over 2. And the area of triangle ADB equals to X times 2A times sinus 60 degrees over 2. Okay? So we cancel here sine of 60 degrees. We canceled also 2, and we canceled a, because we have it on both sides of the equation, and we got that x plus 2x equals to 2a. That is to say 2a equals to 3x. We divided this equation by 3, and we got that x equals to 2 over 3 times a. A equals to 6 over square root of 7 units, so we substitute a by 6 over square root of 7 units, and we found out in conclusion that x equals to either 4 over square root of 7 units, or in terms of numbers, it is equal to 1.51 units. Okay? Thank you very much.